Richard James will present fraction tutorial 2, continuing solving some more problems that require the manipulation of fractions. So there we have our first problem. Here we have a beautiful example of how easy life can be when we are prepared to keep an open mind when we are solving a problem. The upper set of fractions already have common denominator. We may proceed to add the numerators like we normally do when we have common denominators. The result may then be placed over the common denominator. We will also proceed to add the whole numbers, and the whole numbers are 5 and 3, and that will give 8. So we have the numerators. When we add them, 2 plus 5 is equal to 7. Then we add these 5 plus 3 is equal to 8. Now, some students, by the time they get to number 7, they are converting mixed numbers to improper fractions, and they are doing all of the regular fancy footwork. But at this stage, we should be able to just take a second look at that problem that we have and see how simple it can really turn out to be if we are prepared to identify these as common denominators, add these two fractions, also add the whole numbers, and then presto, we are finished. So there we have it. 5 plus 3 is 8, and 2 over 7 plus 5 over 7 is 7 over 7, and this looks like a whole to me, so we may just call this 1 and say that 8 plus 1 is 9. Of course, 7 divided by 7 is 1, so 8 plus 1 is 9. So any number divided by itself results in one whole. So 7 divided by 7 is equal to 1, and 8 plus 1 is equal to 9. So this that we have right here, looking a little bit cumbersome, is only equal to 9. Right. We may also take advantage of the fact that we have a whole number from which we are required to subtract 2 and 4/5. Right here we have a whole number from which we are required to subtract 2 and 4/5. So 4 minus 2 and 4/5. The result is 1 and 1/5. Take a look at the following process. We will take a look at a particular process that we have right there. So we are saying 4 minus 2 and 4/5, and that is equal to 2 minus 4/5. How did we arrive at that? We say take these 2 from the 4, because if we are subtracting 2 and 4/5 from 4, what are we actually doing? We are subtracting the 2 from the 4, and the result is 2, and then we now have to take the 4/5 from the remaining 2. So 4 minus 2, and then from the result we take 4/5. As we have here, we may also take advantage of the fact that we have a whole number from which we are required to subtract 2 and 4/5. So from 4 we first take away 2. We now have 2 from which to take away 4/5. The result is 1 and 1/5. So take a look at the process. So we take the 2 first, this 2 from the 4, and we get 2. Now we need to take 4/5 from the result. Now this 2 is written as 1 plus 1. So 1 is right here, and then the other one is written as 5 over 5, because 5 over 5 is 1. Why do we say 5 over 1? We may say 7 over 7 is 1, 9 over 9 is 1. But because we want the same denominator that we have here, we use 5. So 5 over 5 to maintain the denominator, so that when we are doing the subtraction, we may subtract quite easily because the numbers have the same denominator. So 1 and 5 over 5, now we subtract 4 over 5. So 5 over 5 minus 4 over 5 is 1 over 5. So the result is this one, and the result of taking the 4 over 5 from the 5 over 5, which is 1 over 5. And that's all there is to it. Now let us take a look at that under the microscope. In subtracting 2 and 4/5 from 4, we need to take away the 2, then take away the 4 over 5. Take away 2 from 4 first. So we have the 2. And then we need to take away the 4 over 5. So 4 minus 2 is 2. Next we subtract 4 over 5 from 2. Now 2 is 1 plus 1. One of those is written as 5 over 5, and the other remains. So we take this 2, write down 1, and take the other one and write it as 5 over 5. Right. And then from that 5 over 5, we take 4 over 5, which is 1 over 5. So the result is 1 and 1 over 5. So finish up by subtracting 4 over 5 from 5 over 5. And there we have it. A CXC CSEC candidate should be able to carry out the entire process mentally in a few seconds. So that is how we are required to think at this level. At the earlier level, we were given fractions with the same denominator. At this level, we need to be able to create fractions with the same denominator and manipulate them quite easily mentally. Some students take 2 from 4, then add the fraction 4 over 5 to the result. I've seen that. So we have, they take the 4 minus 2 and they get 2, and they say 2 plus 4 over 5 and they get 2 and 4/5 for their answer. This is how they make a meal of a simple problem. Convert 1 and 1/5 to an improper fraction, because we have that now. So convert it to an improper fraction. So 1 and 1/5 to be converted to an improper fraction, we have 5 ones 5 plus 1 is 6. So 6 over 5. 5 ones 5. Then that 5 plus 1 is equal to 6. There we have it, and the denominator will be the same. After which time, what do? Do the reciprocal of the divisor and change the division sign to multiplication. We are dividing by 6 over 5 and change the sign to multiplication. Then we reduce by a common factor of 3. 3 into 6 is 2, and 3 into 9 is 3. Sometimes it pays a lot to have information on the slides, and some may say that I am putting a lot of information in detail on the slide. But what we are refusing to understand is that not every single human being can hear. Therefore, if someone cannot hear and the person can read, the person should be able to follow the steps also. So I'm not living and catering for people who are like me, who can hear. I'm also preparing for students who cannot hear, which is considering those individuals who might not be at a disadvantage to us, but they are just different from us. We are also catering for them on these slides or in these video presentation by also writing a lot of information on the slide. But what I realize, sometimes I would probably make a mistake by saying 3 into 6 is 3, and then when I realize I have the information there already, 3 into 6 gives 2. So sometimes these informations that we have on this slide help in correcting me or ensuring that I do not make too many errors. So finish up by multiplying the resulting numerators and denominators. So we have 3 5s 15 and 1 2 2. So we have the result is 15 over 2. We will return to our old ways converting mixed numbers to improper fractions. We did not do that here. Well, in the end, we converted the 1 and the 1/5, but we did not do that at the beginning, as we are accustomed to doing when we are solving problems like these. So let us go straight ahead and convert the mixed numbers to improper fractions, and we are there again. We'll not do this through the entire set of tutorials on fractions, so let us take advantage of the fact that we are naming each component, the numerator, the whole number, and the denominator. Then we do what? Multiply the denominator by the whole number. 7 times 3 is 21. Then we add the numerator. 21 plus 2 is 23, and that 23 is the result of the new numerator, and the denominator will be the same as before. And there's another one. 7 multiplied by 1 is equal to 7. Then 7 plus 1 is equal to 8. That is the 8 over 7. Then we do what? 3 times 1 is 3. Then we say 3 plus 2 is 5. So 5 over 3. In this step, we make use of exclusive denominators in adding the fractions, and also reciprocate the fraction that we are dividing by, and change the division sign to multiplication. So exclusive denominators, what do we do first? Find the denominator of the answer by multiplying these two denominators. 7 3s 21. Then the two numerators, or the two numbers that will occupy the numerator position, we have 23 times 3 is 69, and the 5 times 7 is 35. And then we will do the reciprocal of the fraction right there. And what do we know? That we have to add these. So 69 plus 35 is 104. So 104 over 21 multiplied by 7 over 8. 8 into 8 gives 1, so we are reducing by a common factor of 8. And then 104 divided by 8 is 13. And 7 into 21 gives 3. And 7 into 7 gives 1. And we will no doubt finish up by saying 13 times 1 is 13. And 3 times 1 is 3. So we will have 13 over 3. So finish up by multiplying the resulting numerators and denominators. And we have them right there. It was a bit surprising to some of my students that I realized that 104 is divisible by 8. That should not be so difficult, because 104 is obviously a multiple of 4. However, not every multiple of 4 is a multiple of 8. So 104 is obviously a multiple of 4. However, not every multiple of 4 is a multiple of 8. So how did I recognize very quickly that 104 is divisible by 8? That is what we are looking at. How I was able to do that. What is certain though is that every other multiple of 4 is a multiple of 8. 100 is a multiple of 4, and we are sure that it is not a multiple of 8. Therefore, the next one after 100, which is 104, must be a multiple of 8. So let us look at the multiples of 4. Notice them: 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. Those are multiples of 4, some of them. So some multiples of 4, we have them right there from 4 to 40. What about the multiples of 8? Only the 8, the 16, the 24, the 32, and the 40. Notice that every other one is a multiple of 8. Therefore, if we are at a particular multiple of 4, and that multiple of 4 is not a multiple of 8, then the next one has to be a multiple of 8. So if this is not a multiple of 8, then this one has to be a multiple of 8. This one is not a multiple of 8, this one is a multiple of 8. Like that. There therefore should be no difficulty, seeing that if we have two consecutive multiples of 4 that are 100 and 104, if one is not a multiple of 8, then the other one must be a multiple of 8. What I did in less than a second is make use of a known multiple of 4, which is 100. So the one known multiple of 4 that is close by to 104 is 100, and I'm making use of 100. It is not a multiple of 8. 100 is not a multiple of 8. Therefore, the very next multiple of 4 must be a multiple of 8. So it is not a multiple of 8, that is 100. Then 1 exactly following it, which is 104, must be a multiple of 8. For us, it might be a bit magical, but for older mathematicians, there is no alarm. They always know their 13 times multiplication table. Also, working with digits over a period of time should cause us to be familiar with the multiples of 13. If not, such a deficiency can cause you to think that 91 is a prime number. So you may think that 91 is a prime number because you are not aware of your multiples of 13. Well, 91 is not a prime number, and you will see that coming on multiple choice papers especially, they are asking you which one of the following is a prime number, and they have 91, they have 93, they have 57, and so on. And maybe they give the numbers in the 90, so they will give which one is a prime number. They give 93, 91, 97, and another one, and then you are required to identify the prime number in that set, and you cannot do that quite easily because you are jumping to say that 91 is a prime number when it is not. Let us go straight ahead as usual, converting the mixed numbers to improper fractions. Notice also that the large fraction bar is replaced by its equivalent, which is a division sign. So we have done that here, replacing the large fraction bar with a division sign. And let us go straight ahead and do some conversion. So 6 5s 30 plus 4 is 34. So 6 5 30, 30 plus 4 is 34. That is our new numerator. And there we have our denominator. Some will say, Richard James, aren't you tired of converting mixed numbers to improper fractions? No, I'm not tired. What I'm doing this for, in order that if you do not watch all 5 fraction tutorials and you are only capable of watching one, that you should be able to learn something from that single one. We have 5 of them, but if you can get a hold of only one, then you should learn from that one. So I'm not taking anything for granted. So we have 3 4s 12. 12. 3 4s 12. 12 plus 2 is 14. 14 over 3. Then we have 3 3s 9. 9 plus 2 is 11. 11 over 3. Good. We need to find the difference between the two fractions, of which one of the denominator is twice the other. Those two fractions may be brought to the same denominator by multiplying the smaller one by 2. By so doing, the value of the fraction will change, so we need to multiply the numerator by 2 also. Additionally, we find the reciprocal of the fraction that we are dividing by and change the division sign to multiplication. Right. So we have 34 over 6 minus 14 over 3. We multiply the 3 by 2 to get 6. Cannot leave the 14 over 6. we need to multiply the 14 by 2 also, and that is 28. So there we have it, and we multiply by 2 to get 6, but we cannot leave it like that. We have to multiply the 14 also. So the result is 34 over 6 minus 28 over 6. Easily the fractions are brought to the same denominator, and we have the 11 over 3 that we need to reciprocate and replace the division sign with a multiplication sign. As we will see, the next step will work themselves out. We may begin by finding the difference between the numerators of the fractions that have the same denominator. So the next step will work themselves out. So let's see if they will work themselves out. So we have (34 minus 28 is equal to 6). We have it right there. And then we have the 3 over 11. But of course it is 6 over 6, and 6 over 6. 6 divided by 6 is 1. Anything divided by itself is 1. Then we take the 1 and multiply by 3 over 11, and that will remain as 3 over 11. Any number divided by itself is equal to 1, and 1 multiplied by any number will result in that same number. So 3 over 11. And that's all there is to it. In this particular case, well, this is a breath of fresh air. So we have a little bit of deviation from what we are accustomed to. In this particular case, the upper set of fractions are being multiplied. The first step is a combination of 3 activities. 1, the numerators and the denominators are multiplied. We are talking about for the upper set of fraction alone. The numerator and denominator, they are multiplied. The lower mixed number is converted into an improper fraction, which is this one, converted to an improper fraction. The large fraction bar, which is this one, is replaced by a division sign, and that is 3 in 1. So we have 3 over 50 when we say 3 ones, as we have there 3, and 10 fives, 50. And then the 2.5 will be converted to an improper fraction by saying 2 times 2 is 4, and then 4 plus 1 is 5, so 5 over 2. And what will we do? We are dividing by 5 over 2, which is the same as multiplying by its reciprocal that we did not do on the previous slide. The final 2 steps will be completed in one, and this slide we will find the reciprocal of the divisor and change the division sign to multiplication, and we will reduce the resulting expression by a common factor of 2. So the final 2 steps we will complete in one. We will find the reciprocal of the divisor and change the division sign to multiplication. That is only one step. Doing the reciprocal and changing the division sign to multiplication, that is one step, or one thing. And the next thing we will do is reduce the resulting expression by a common factor of 2. So we are saying reciprocate and change the sign, that's one thing, and then we will reduce by a common factor of 2 by saying 2 into 50, or 50 divided by 2 is 25. Then we say 2 into 2 is 1. Then we finish up by multiplying the resulting numerators and denominators. So 3 ones 3, and 25 times 5 is 125. Lovely. More. Here we have a set of familiar circumstances. We notice an occurrence from the previous slide, namely the multiplication of the first set of fractions. However, unlike our experience on the previous slide, we need to convert mixed numbers to improper fractions. So here we have like on the previous slide, the upper set of fractions are being multiplied. But we need to convert mixed numbers to improper fractions first, and that we did not do on the previous slide. So 5 3 is 15, and 15, that's right, but let us name those first. So we are, as a matter of fact, identifying as usual the components. Then we say 3 5s, 15, multiplying the denominator by the whole number, and then we say what? 15 plus 3 is equal to 18, and that is our new numerator, and the denominator is the same as before. Then we say what? 3 ones 3 plus 2 is 5. 3 ones 3, 3 plus 2 is 5. Then we say 2 sevens 14, 14 plus 2 is 16. Right, 16 over 7. Next, we reduce the fractions by a common factor of 3, then by a common factor of 5. So we have 18 over 5 multiplied by 5 over 3, and we will reduce that by a common factor of 5 and by a common factor of 3, but 3 goes first. 3 into 3 is 1, and 3 into 18 is 6. Then of course 5 into 5 is 1, and 5 into 5 is 1. There. And all that is left is for us to multiply the numerators and the denominators. So finish up by multiplying the resulting numerators and denominators. So 6 multiplied by 1 is 6, and 1 multiplied by 1 is 1. 6 over 1, which is just 6. And there we are going down to the next one. Any number divided by 1 is equal to that same number. So 6 divided by 1 is equal to 6. Realizing the simplicity that exists, we return the third improper fraction to its mixed number form. So we recognize that it will be simpler for us to just say 6 minus 2 and 2 sevens. How do we do that? We say 6 minus 2 is 4, and then write 4 as 4. Write 4 as 3 plus 1. So 3 plus 7 over 7. And from that 7 over 7, we take 2 over 7. So we have, in fact, 3 and 7 over 7 minus 2 over 7. So the 7 over 7 minus 2 over 7 is 5 over 7, and we have 3 and 5 over 7. So from 6 we need to take away 2, and we need to take away 7 over 7. We need to take away 2 over 7. Take away 2 first. So we take away this 2 first, and we get 4. Now we have 4 minus 2 over 7. So 4 is equal to 3 plus 1. So we'll write 1 as 7 over 7. So we have 3 and 7 over 7, which is 3 plus 1 is 4. It is the same 4. But 3 and 7 over 7. Now we take 2 over 7 from that. What do we get? 3. 7 minus 2 is 5. So 5 over 7. So 3 and 5 over 7. So that is a simple process if we can do it mentally. Of course we can do that mentally. We say 6 minus 2 and 2 sevens, and we take the 2 from the 6 first, and write the 4 as 3 plus 1, which is 3 and 7 over 7. Then we take away the 2 7 from the 7 over 7, so we have 3 and 5 over 7. It is always easy to subtract a mixed number from a whole number. Take out 1 and rewrite it as something over something. Then subtract a over x or x over x. Why we say x over x is because we are trying to be general. So if the fraction that we are using has a denominator of 7, it will be 7 over 7. If it has a denominator of 3, it will be 3 over 3. And then we are about to take away something over 3. And that is what this general a over x is for. But I'm sure that by the time we exhaust all of these tutorials, then we would have completed an entire course in manipulating fractions in a proper way. As a matter of fact, we will take a look under the microscope at these processes. If not on this tutorial, then on the other one. Now we are with the type of problem that plagued us in the early part of these tutorials, namely the sum or difference of the first set of fractions. By now, converting mixed numbers to improper fraction has become second nature, or some may say boring, or some may say monotonous, depending on the way that you want to view it. So we have 3, 2, 6. 6 plus 2 is 8. 8 over 3. What is the other one? 6 times 1 is 6. And 6 plus 5 is 11. 11 over 6. Some students are very happy that we only have 2 of them, and some were wishing that we only had 1. So from here on, the solution of the problem is quite analogous to the one that we have solved on previous slides. Find the difference between the two fractions of which one denominator is twice the other by bringing them to the same denominator in the usual way. Also, reciprocate the divisor and change the division sign to multiplication. So there we have exclusive. No, that's not exclusive, because one denominator is twice the other. So all we need to do to get this to be a 6 is multiply by 3. Cannot do that alone, multiply the 8 by 3 also. What we need to do with this 3 to make it into a 6 is multiply by 2. Right. And we cannot leave the 8 untouched. We need to multiply that by 2 also. So multiply by 2 over 2, we get 16 over 6 minus 11 over 6, and that is 5 over 6. It's easy as that. And then we do the reciprocal of the divisor and change or replace the division sign with a multiplication sign. We may proceed to reduce these measly fractions by a common factor of 3 after we have found the difference between the numerators of the fractions. And some students are saying, how long is Richard James waiting to use that word measly? Because I use that a lot when I am doing my personal tutorials and also when I am teaching my classes. We may proceed to reduce these measly fractions by a common factor of 3 after we have found the difference between the numerators of the fraction, and the difference between 16 and 11, because they have the same denominator, is 5. So we put 5 over 6, and we proceed to reduce by a common factor of 3. 3 into 6 is 2, and 3 into 3 is 1. So what do we know? 5 ones 5 and 2 twos 4. Finish up by multiplying the resulting numerators and denominators. So 5 ones 5 and 2 twos 4. That's all there is to it.